Grade 7 to 9 revision questions, week 1. Question 1. The first line tells me that y is directly proportional to x, so I'm able to make this equation y equals kx, creating that multiplier of proportion. And then the next line tells me that x is inversely proportional to t. When it's inverse proportion, we create an equation that has a division. Okay, now I'm going to substitute in these values that they've given me here to be able to reveal the value of k in each relationship. So I'll just quickly write that again. So for the first one, it tells me when y is 8, the value of x is 2. If I divide now by 2 to get k on its own, I get the value of k is 4. So I can now rewrite this to say y equals 4x. That's my first relationship. My second one, just write that again, I had x equals k over t. It tells me when x is 2, t is 6. So to get k on its own, this time I'm going to have to multiply, and I get the value of k is 12. So the equation I can now form is that x equals 12 over t. Now, the question they're asking me is asking me to find the value of t when y equals 96. So there is no x mentioned. So what I'm going to do is combine these two relationships to eliminate the x. Now, the method is to make x the subject of one equation and use that to substitute into the other equation. Now, I'm going to use this version here because it already has x as a subject, and I'm going to substitute that version of x into the first relationship there. So I'm going to do it in black ink over here. So I get y equals 4 lots of this version of x, which is 12 over t. So I've just substituted in x for what x is in that red box. Just to simplify that, I'm going to multiply that whole number by that fraction. 4 times 12 is 48. The impact happens on the numerator there over t. So that's the relationship of y in terms of t. And now it says find the value of y when t is 96. I'm going to quickly substitute that in. Y equals 48 over 96, which is my answer. You can simplify that to a half if they wanted you to, but that is your answer right there. Question 2. To complete the square, you want to work with an x squared value, an x squared which has a coefficient of 1. So basically, we don't want to see anything in front of x squared. So when that happens, the first thing you do is factorize that out. Before I mention that, I'm going to just say when we complete the square, we're working with the first two terms of that quadratic expression, the x squared one and the x one, and I'm going to deal with the minus 5 separately. Okay, so here we go. So I'm going to take out the 2, factorize the 2, and it leaves me with x squared minus 6x, and close that bracket now, and we're going to deal with them negative 5 afterwards. Now, the reason why I wrote it in blue is because I want you to see that I'm only completing the square on that blue part there. So it's still multiplied by 2 on the outside. Complete the square. Send me a message if you are not sure what I'm doing or how to complete the square. But what you do is you halve the b term, the term that is a coefficient of x. So that gives me 3. Set up your bracket, square it, and then subtract that number squared. Okay, so that's the completing the square step actually done right there. Now I'm going to expand this giant bracket that I've created, just like expanding brackets, multiplying that out, and I get 2x minus 3 squared. 2 times 9 is negative 18, or times negative 9. And now we're going to deal with the negative 5 there, minus 5. X minus 3 squared minus 23 is my answer. And then it says state the coordinates of the vertex. Now the vertex is the turning point. And the notes here for you is that when you complete the square, so even if you have a coefficient of that bracket and you get x plus, let me call it b squared plus c, the vertex or that turning point will always be the negative version of b and whatever you see there for C. So basically swap the sign for B and keep your C looking the same, and at the value of A doesn't impact this. So my answer is positive 3, comma, negative 23. Question number 3. This is called solving a quadratic inequality. The first thing we're going to do is solve it like it's a quadratic equation. We're going to try factorising first. If that doesn't work, we go to quadratic formula, etc. So let's go ahead and actually it does factorise. You can take your time and pause it and try and factorise it yourself. But if I look at factor pairs of 48, if I work with let's see, 3 times 16. No, that won't do it. 4 times 12. That would do it. 4 and 12. And they both need to be negative. So that would be negative 4 take away 12 will give me negative 16. And I've got negative 4 times negative 12 gives me positive 48. So I've got it. So my key values are x equals 4 and x equals 12. Now, at this point, there are 2 ways to solve this inequality because I've got to figure out what way the signs go. Okay, so the first method is to quickly whip up the graph. So I'm going to whip up the graph and it crosses the x-axis at 4 and 12. And if you don't know how I'm sketching this graph, then send me a request for a video to show you how to sketch quadratics. That y-intercept is 48, and that's a nice smiley face there. Now, this question is asking me what values of x makes has a negative output. What values of x make this expression come out as negative? And you can see that these are the y numbers that come out as negative y numbers. So the x inputs for those, you can see here, would be that all values between 4 and 12 will give me those negative y values. So the region where x squared minus 16x plus 48 is negative, is less than 0, is that. The other method I could have done, if you don't like that, is to draw a number line and just put those critical values on. So we've got 4 and we've got 12. And just understand that this creates 2 regions. You might be thinking, I could see 3 there. It creates 2 regions. We've got the middle region, that's 1. And then we have the outer regions, and that's the same region, okay? So what you do is you always set that up. You set 2, the outsides are the same, the middle is different. And then you choose a coordinate to see which is the correct region that fits my inequality. Now, you're in a test when you do this, so we want to work quickly. So choose a number to substitute. That's nice and easy. I'm going to choose the number 0. That's what I always do. I found out where 0 is. 0 is in the pink area, so I'm going to substitute 0 in. And the cool thing about substituting 0 is that we literally can just swipe out terms. 0, 0. So we're left with this statement. 48 is less than or equal to 0. Well, that's not true. So that means that the pink regions are false and the blue region is true. So that means x is greater than 0 for all the values between 4 and 12. Just keeping that inequality there. Question number 4. For these questions, it's quite handy to do a little diagram to go with your working to help you get your head around what's going on. So we have a circle, and circles that are of the form x squared plus y squared have a centre which is the origin, and the radius would be the square root of 10. Okay, so I'll just rub that out. The radius will be the square root of 10. So I know that I have a circle around my origin, and the radius is root 10, because the formula for a circle is x squared plus y squared equals the radius squared. Okay, and then it says find the equation of the tangent to the circle at 1, 3. Okay, so that means that if we find 1, 3, it's on the circle, so we know it's not beyond the red line. So let's use a green pen for that. So let's say it's over here. Of course, it's 1 something. So they're talking about this line here. That's the tangent to the circle at 1, 3. It may not be exact, but it just gets my head around what's going on, and at least I can see there that it's got a negative gradient. Okay, so we've set that up. Now let's remind ourselves how to find the equation of a straight line. The equation of a straight line would look like this: y equals mx plus c, where m is the gradient and c is the y-intercept. So we're going to find the gradient first. So the concept that I need to understand to find the gradient, we'll start with the gradient, is that the tangent, that green line, and the radius to the circle, that black line, are perpendicular to each other. They meet at a right angle. And there's something that we should know about two lines when they meet at a right angle. When one line has the gradient of m, the other line is the negative reciprocal of m. So what I'm going to do is find the gradient of my black line. Now the gradient of my black line, if I draw a little right angle triangle, because of the coordinate, I can see that it will be 1 across and 3 up. So the gradient, I'm going to call the gradient m, equals change in y over the change in x, which is 3. That's the gradient of my black line. So that means the gradient of the line I'm interested in would be the negative reciprocal of that, negative 1 over 3. So I use this m that I've just found, plus I use the coordinate 1, 3 to plug it into y equals mx plus c, and then I should be able to find the y-intercept and get the equation of the line. Okay, so here we go. Y is 3. The gradient is negative 1/3. X is 1. And then we're trying to solve for C. So I've got 3 equals 1 times negative 3 is negative 1/3 is negative 1/3 plus C. So what I'm going to do is add on the third. So I actually get 3 1/3 equals C. I can change that to 10 over 3 in a minute if I want. Okay, let me make some space. So going back to my green pen, I now have the gradient and I have the y-intercept. So now I have the equation of the line, which is the tangent. It's y equals negative 1/3 x plus, I'll change that to an improper fraction. 3 times 3 is 9 plus 1 is 10 plus 10 over 3. You may see it tidied up a little bit. If I multiply everything by 3, it may look a bit nicer like this. 3y equals negative x plus 10. Looks a bit tidier, but it doesn't really matter. I would have found it with what I wrote on that first green line. Question number 5. So this is trigonometry in 3 dimensions. The way I get students to solve it is by pulling out some two-dimensional representations of what's going on. So you'll see what I mean here. So we're calculating the size of angle DBX, which I'm going to show in yellow. So D to X to B, this one here. So it's that angle there that connects D via D to X to B. We're trying to find that angle there. And looking at that, it doesn't look like a right angle, so we know we're going to need sine and cosine rule. And so we can look at what sides we want of this triangle. In fact, let me color code each side so we know what we're looking at. So we've got three sides. We've got this green side. We'll keep that one yellow. And we've got this blue side here. So let's see if we can find those three sides, then we can figure out the angle by using the cosine rule, which is the rule that we need one angle for. So I'll just quickly write out the cosine rule here. The cosine rule is that c squared equals a squared plus b squared minus 2ab cos c. So I knew it wasn't the sine rule because that would need two angles. I'm only interested in one here. I'm just going to color code A and B. So let's say that A is our yellow one. There's our A again. And our B is our green one. Color code that. And then opposite the angle, let's make the angle blue to make it really obvious. All right, so opposite the angle, we're looking at C there. And that's the angle there, which is blue. Okay, that's enough playing with colours. All right, so the first line I'm going to find is the blue one because it's just a diagonal on that top rectangle. So I'm just going to use Pythagoras to find that. So if you can see, if you visualize it from a bird's eye view, from a plan, we've got these vertices here and BD is that corner there. So using Pythagoras, let's label this, that will be 6 centimeters back and that will be 8 across. So I'm using a squared plus b squared equals the line we're trying to find, bd squared. So I'm just going to type it into my calculator just like this. I'm going to put in the square root of this as a little shortcut to Pythagoras. Just go straight into that square root if you've got a calculator. So I'm pressing square root of 6 squared plus 8 squared, and that gives me 10. Okay. All right, let's do the green one. Okay, so if I pull out that green one, it's actually the hypotenuse of this diagonal here. So with F in the corner, we have X there as the middle, and then we have B up there. So we're looking at the green line there, BX, is the hypotenuse. Now, I have this dimension 5, but Fx is, let's just draw it in green, Fx is halfway across that diagonal on the base. Now that diagonal on the base is actually the same as the diagonal on the top, which we just found the distance of, which was 10. That tells me that this is going to be 5 as well. So I have here the square root of 5 squared plus 5 squared. That would give me my bx I'm looking for. So let's put that in the calculator. And we get, calculator simplified it for me. For bx, we get 5 root 2. Okay, and now we're going to do the same for the yellow one, but actually, because we are in a cuboid, it actually has the same dimension. So if you think about it, so drawing it this way here, which has x over there, h here, and d here, we still are 5 up, and we still have that distance of 5 across. So it's actually exactly the same. So I've got those distances. So I'm going to tidy this up a little bit, do some rubbing out, and then we're going to apply the cosine rule. Okay, so let's draw this triangle as a two-dimensional representation. So we have the yellow one side, we have the green side, And then we have the blue side there. I'll write in black now. And that's the angle we're trying to find. So we worked out that that was 10. And we worked out that that was 5 root 2. And we worked out that this is also 5 root 2. Okay, and we are trying to find the angle between them. All right, so I'll just make a bit more space quickly. So now we're going to apply the cosine rule. So we have 10 squared equals 5 root 2 squared plus 5 root 2 squared minus 2 lots of 5 root 2, 5 root 2, and then cos C. Okay, so tidying that up a bit, I get 10 squared. I'll use another colour because it's in the way of the other side. 10 squared. And when I square a surd, let's just do this over here. So if I'm doing 5 root 2 times by 5 root 2, I get 5 times 5, which is 25. And then when I do the root 2 times root 2, that comes out as 2. Root 2 times root 2 is 2. So I get 2 times 25, so that's 50. So that one's 50 and that one's 50. So I'm going to add that together, and that gives me 100. And here I have that calculation again. Work that out up over there in blue. That's 50 times by 2 gives me 100 again. So here we go. Minus 100 cos C. And then I'm going to rearrange the equation to get cos C on its own. So I'm going to bring everything to one side. I'll just rub this part out just to make some space. There we go. So bringing the 100 cos C to the other side to make it positive. And then I'm going to bring, so I've got 100, and I'm going to bring the other 100 over, which is 10 squared. Just take away 10 squared. I've left it as 10 squared so you can see it. That's 100 take away 100 is 0. So we have cos C equals 0 divided by 100. So we have cos C equals 0. Okay, and if you inverse cos that on your calculator, you would get the value. So I have to press shift cos of 0, and it comes out as 90 degrees. So that angle is actually 90 degrees. Well, if this did come up on a non-calculator paper and you had to figure out what that is, we would have to think about understanding the cos curve. And here in green, you can see that cos 90 is indeed 0. And that's the answer. Question 6. What we need to understand here is that in a velocity time graph, the distance is represented by the area under the curve. Or line. I'll say the area under the graph. Okay, so it says, what is the distance covered in the first 40 seconds? So if I shut it off at 40 seconds, we want to find the area of this shaded region here, which I can chop into a few different shapes. We can chop it into a trapezium and a triangle. I could have chopped it down here, made 2 trapeziums. So we're presented with quite a few different options. I think I'll go for my first one, which is a trapezium and a triangle. Here we go. Let's color code it. Let's make this trapezium purple. So we're going to find the area of the purple trapezium, then the blue triangle. So area of a trapezium is half A plus B H, where A plus B is the parallel sides. So the top has a length of, let's see what's going up in. It's going up in 5s. That's 10, 20, 25. So the first A is 25, and the bottom is the 40 seconds. So we're going to add that together, and that gives us 65. And then we're going to multiply that by the distance between them, which is 10. So that gives us 65 times 10 gives us 650. And then that's the height there that I used, that I found that 10. And then I'm going to half that, which gives us 325. Okay, that's the purple. And then now let's look at the triangle. Every triangle is half base times height. All right, so I'm going to do base times height, then divide by 2. The base of that triangle is just 10 across. And the height of that triangle goes from 10 to 18. That's 8 up. And then I'm going to divide that by 2. So that's 80 divided by 2 is 40. And then when I add that together, I get a grand total of, I'll put it over here, let's add that together there. We get a grand total of 365. Let's see what they're in meters, because this is in meters per second. And that's your answer.